Well, welcome back. We're starting Chapter 8, Section 1 today on geometric mean and Pythagorean theorem. What is the geometric mean? The geometric mean between two positive numbers, let's say we call one A and B, 5 and 10, just any positive numbers, is another positive number that we'll call x, where x squared equals a times b. So, in other words, we can set it up as a proportion like so, where a and b are the two numbers you're finding the geometric mean between, and x is the geometric mean. It's the new number you're looking for. So you would actually have numbers here for a and b, and x would be your variable. Well, if we cross multiply these two, then we get x squared equals a times b. That's where this comes from. And then remember that anytime we want to undo squaring, we have to take the square root. So when we take the square root of both sides, we end up with our new number being nothing more than the square root of our two numbers multiplied together. So let's do some examples here. Okay, again, if x is the geometric mean that we're looking for of two numbers a and b, then it's going to look, we're going to set up a proportion. We're going to put our first number here at the top, and we're going to put our second number here at the bottom of the second fraction. And then our unknown x in the two means positions. These are called means. These are called extremes. Again, we cross multiply and we get x squared, because x times x is x squared. It is not 2x, it is x squared, and that's going to equal a times b. Take the square root of both, and you get x equals the square root of a times b. So now let's put that into practice here. If we want to find the geometric mean of 5 and 20, we're going to set up our two fractions, make a proportion, where 5 is at the top, 20 is at the bottom. It really doesn't matter which one you put in which position, because 5 times 20 is the same as 20 times 5. I just usually put them in the order they're in the problem. Now, if we cross multiply, what do we get? X times x is x squared, and 5 times 20 is 100. Now think, what is the next step going to be? What did we do up here? How did we go from x squared to x? We took the square root. So what is the square root of x squared? And what is the square root of 100? X equals 10, and it's going to be the positive. It's always going to be the positive root. So here's another example. We want to find the geometric mean between 25 and 7. So see if you can think in your head how you're going to set that up. What are your two fractions going to be in your proportion? Again, it doesn't matter which one of these you start off with. I usually just go in order that they appear in the problem. So we're going to put 25 over x, and then we're going to put x over 7. What do we do next? Hopefully you said cross multiply. These are called the cross products. So the cross product of x times x is x squared. The cross product of 25 times 7 is 175. Now what's our next step? It's to take the positive square root of each side. So again, we're going to take the square root of x squared and get x. Take the square root of 175 and get the square root of 175. If you simplify that, you get 5 times the square root of 7. And anytime you leave a radical or a square root in your answer, that is the exact value. We are not rounding anything. We are leaving that as the square root of our answer. So know that a square root means exact value. Sometimes your instructions will say, find the exact value of blah, blah, blah. You need to know that that means to leave the square root in your answer. If we use our calculator to find the square root of 7 or the square root of 175, then we get a decimal. Because we rounded that decimal, it is an approximate value. So this little squiggly equal sign, that means approximate value. You need to know the difference. This is exact, this is approximate. Exact leaves the square root in their answer. So pay close attention to your instructions or your directions. If it says exact, you're going to leave it as a square root, but if it says carry it to the nearest 10th or the nearest 100th, you're going to have to use your calculator to find the decimal value. Everyone's calculator is different, so you need to make sure you know where the square root button is on your calculator. Okay, so the geometric mean is about 13.2 in this problem. Again, it would depend on what your instruction said as to which answer you would box in. Find the geometric mean of 3 and 12. So how are we going to set this up? Start off with our first number and put it over x. Then put the second number under x. We're then going to find the cross products. So x times x is x squared. 3 times 12 is 36. Last step is to take the square root of both sides. So x equals 6. We're going to choose the positive. X could also equal negative 6 because negative 6 times negative 6 is also 36. But when we're finding geometric mean, we always use the positive square root. So our correct answer is B. Okay, a theorem. First theorem of this chapter. If the altitude, remember what altitude is, it goes from a vertex straight down to form a right angle with the opposite side. If it's drawn from the vertex of the right angle, so you're going to look for this right angle box in your big triangle, and you're going to draw your altitude from that vertex, then the two triangles formed are similar to the given triangle and to each other. Remember what similar means. Similar means same shape, but different sizes. So they're in the same proportion. Do you see that this altitude splits the big triangle into two triangles? We have triangle ACD, and we also have triangle BDC, and then the big triangle ACB. So we have three triangles here. When that altitude is drawn from the right angle vertex, all three of those triangles are similar to each other. They are in proportion, same exact shape, just a different size. So here's the smaller triangle that we can pull out. We can call it ACD. If you look at its orientation, ACD. Then we pull out the medium-sized triangle. Again, it's similar. So C is its vertex up here, D, the right angle, and B. And then we have our original triangle. So we can make similarity statements. The small triangle, if we went from A to D to C, we're going the short side and then up the long side. We need to name the other two triangles in the same orientation, the same pattern. So we're going to do the short side, which is C to D, and then the long side, which is D to B. So we would call this triangle CDB. Then we have to do our big original triangle in the same direction. Short side is A to C, and then the long side is C to B. So if you need to turn your paper or draw all of your triangles in the same orientation so that you can match the parts correctly, do whatever you need to do, but you have to put these in the right order. You have to match the corresponding parts. We've been doing that for a couple chapters now. angle A has to match angle C in the medium triangle and has to match angle A in the big triangle, okay, and so on. Okay, so if the altitude creates similar triangles, then we can set up a proportion matching the corresponding parts. So here we need to find CD. Okay, so in the big triangle, this side AC is the long side. Well, the long side in this medium triangle here, or I'm sorry, the small triangle here, is side CD. So I'm going to set up a ratio, set up a fraction comparing those two corresponding parts. So 12 and x are corresponding parts. Let me go through that again. 12 is the long side of the big triangle, and x is the long side of the small triangle. Since they're both long sides, I can make a ratio out of them. Then what else do I know? I know the hypotenuse of this big triangle. It is 15. And I also know the hypotenuse of the little triangle, which is 9. So we're trying to make ratios out of corresponding parts. Remember, we can do that in similar figures. We can match their corresponding parts and make a ratio out of them. Now that I have a proportion, I can just cross multiply and solve for x. So x times 15 is 15x, and 12 times 9 is 108. When I divide by 15 on both sides, I get 7.2. So the height here, this altitude, is 7.2. Okay, so here are my three different triangles. If that helps you, again, to draw them out oriented the same way so you can match your parts, you can see that 15 matches with 12, or it also matches with 9. Okay, so you could set up a ratio either way there. And we were looking for DC or CD, so we would put an X here. Well, that's going to match with the 9 here. So I make a proportion using those matching parts. Okay, let's find BD and AD now. So BD, let me erase these arrows that I just did so they don't get in the way of the new problem. So if we want to find BD, let's put an X there. Okay, so we have these two triangles we're comparing. What are the two matching parts? Well, I have 15 is in the same position as 9, so those two go together. And then I have X in the same position as this 9, so those two go together. So I can make a proportion. I can make fractions out of those two corresponding parts to make a proportion. So I did 15 and 9 here. Again, these are corresponding parts. And I did 9 and X because they're corresponding parts. So it's crucial to get your proportion set up correctly. You know what to do from this point on. It's getting these numbers in the right position. If you move them around, you're not going to get the right answer. So when I cross multiply here, I get 15x and 81. When I divide by 15, I get 5.4. So right here, side BD is 5.4. Now it also says to find AD. Okay, well, where do I see AD? Right here. Okay, what can I match this triangle with, the small one or the big one? I got to have two ratios. So yeah, I have a 12 and a 9 here that match, but I don't have anything in the same position on this small triangle as my AD side. There's nothing to match that X with over here. So I'm going to have to use this big triangle. Let me change colors. That didn't change. Okay, so I am going to match the 15 with the 12 and make a fraction out of those two. And then I'm going to match the 12 here with my unknown side over here and make a fraction out of that. Then I put those two fractions together. So 12 and x, 12 and x, corresponding parts again. Okay, these are corresponding parts. And 15 and 12. Make a fraction out of those right here. Cross multiply, divide, and you get 9.6. So it's all about finding corresponding parts. Now, AD and BD were these two segments right here. We know that the whole thing adds up to 15. So I can check myself by adding my two values and seeing if they add up to 15. And indeed they did. So I know I did it right. Always try to find a way to check yourself. Stops careless mistakes. Well, there's an easier way to do what we did. In a right triangle, the altitude from that right angle divides the hypotenuse into two segments. Okay, it's dividing it into this segment and this segment. Okay, two different parts. And we're going to do something with those two different parts. Our second theorem says this. The measure of the altitude drawn from the vertex of the right angle of a right triangle to its hypotenuse, what we just did, is the geometric mean. Remember that geometric mean? And we had our x here and our x up here, which you can't see in my black. Okay, it's the geometric mean between the measures of the two segments of the hypotenuse. So that hypotenuse is divided into two parts. We're going to put one part up here, one part down here, and we're going to find the geometric mean between those two. When we find that geometric mean, it is the altitude. Okay. So here's my triangle. Here's my altitude coming from the vertex of the right triangle. It splits the hypotenuse into two parts. Those two parts are going to be used in our proportion to find the length of the altitude. Okay, so here we go. I took the 9.6, one side of my hypotenuse, the 5.4, which is the other side of my hypotenuse, and then I put my x's in my means position and set up a proportion. Now all I have to do is cross multiply. Remember, x times x is x squared. 9.6 times 5.4 is 51.84. Last step is to take the square root. So x ends up equaling 7.2. So that is the length of my altitude. If I take the two parts of my hypotenuse, create a proportion to find the mean, then I get the length of the altitude. Okay, so here it is generically. A and B are numbers. They're going to go in the extremes positions, and your altitude is the mean. Okay, so this looks just like the formula we learned for mean, geometric mean. Okay, so let's do an example here. Plug in the numbers that are given to us. If I know that BD, again, mark up your drawing. BD is 6. That's this little bitty sliver right here. And then AD, this big old long thing, is 27. Okay, well, that's my two parts of my hypotenuse. See how my altitude is coming from, I'm going to look for this right angle box. It's coming from this vertex. It's going down. It's hard for me to draw straight on this thing. To the hypotenuse, dividing it into two parts. So those two parts are going to go in my extremes position. And then I put my unknown, which is my altitude. Okay, so I'm finding this value. Now all I do is cross multiply. Six times 27 is 162. Last step is to take the square root. How did I get this? Let's think. What perfect square goes into 162? 81. How many times does 81 go into it? It goes in there 2 times. A perfect square is the result or the product of any number squared. So 1 squared equals 1. 1 is a perfect square. 2 squared is 2. It's 4, I'm sorry. 4 is a perfect square. 3 squared is 9. 9 is a perfect square. I think you get the idea. 16 is a perfect square. 25 is a perfect square. 36 is a perfect square. 81 is a perfect square. What is the square root of 81? 9. So if we can rewrite this as the square root of 81 times the square root of 2. It means the same thing. What is the square root of 81? It is 9. So I change it to 9. But I'm still left with the square root of 2 that I can't do anything about. Is this the exact value or is it an approximate value? You should have said exact, because anytime we leave that square root sign in there, it's the exact value. If we use our calculator to get a decimal, then that gives us an approximate value. In this case, it would be 12.7. You would punch it in 9 times the square root of 2. Okay, so let's do another one here. So I'm going to take the two parts. You got to make sure it's two parts of your hypotenuse. And is it divided by the altitude? Yes, it is. So I have the two parts, 4 and 18. Put them in the extreme position. Fill in the means with the same letter, x. We're going to cross multiply. X squared is going to equal, oops, I'm sorry. X is going to equal the square root of 72, which if you do that on your calculator is 8.5. We knew it had to be between 8 and 9 because 8 squared is 64 and 9 squared is 81. Well, this was 72, so it needed to be between 8 and 9. The only answer is 8.5. Third theorem. If the altitude is drawn to the hypotenuse of a right triangle, then the measure of a leg of the triangle is the geometric mean between the measures of the hypotenuse and the segment of the hypotenuse adjacent to that leg. Blah, 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 blah. I bet I sounded like Charlie Brown's teacher. Mwah, 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 mwah. Here's what it means. So here's our altitude. When we draw it, again, it's going to split that hypotenuse into two parts. This time we're finding one of the legs. The leg here is the geometric mean between the entire hypotenuse and the part of the hypotenuse that connects to that leg. So A is the geometric mean between the entire hypotenuse and the part or the piece of that hypotenuse that touches that leg. This leg follows the same pattern, but it's going to be the piece that touches it. So let me do it here where you can see it better. The leg is the geometric mean between the entire hypotenuse, C, this whole thing, and the piece that touches that leg, which is E. Okay, you have to remember the pattern. Yes, you may have to study. You may have to go home and memorize these things. So find C and D in this triangle. Okay, well, I can't use the whole hypotenuse because I don't know C. And sometimes you have to do these things not in alphabetical order. First thing I see here is a right triangle, and I have the two legs. Anytime I think of right triangle, I have to also consider the fact that I might use Pythagorean's theorem. That never goes away. So I will have to do that here to find D. This is my hypotenuse, so I have to square my two legs. That's a 5. And that's going to equal D squared. So 25 plus 100 equals D squared. 125 equals D squared. So the square root of 125 is D. Okay, here's another way we could set it up. I have similar triangles here. You just have to see the way they're oriented. Here's my small one, 5, 10, D. Here's my medium one. 10 is the short side. My medium one's right here. Okay. My long side is C. We don't know the hypotenuse. And then if I do my large one with the same orientation, the short side is D. The long side we don't know. And the hypotenuse is 5 plus C. So I can set up a proportion here of corresponding parts to corresponding parts. So that's another method we can use here. 5 over 10 equals 10 over C. Only because these are similar triangles can I do that. So this is a way to solve for D. This is a way to solve for C. 5C equals 100. C equals 20. So you could start either way. You could have done either one of these first. It does not matter. Now that I know C, I can find D using my geometric mean, the rule that we just learned. Because D is going to be the geometric mean between this whole thing. What is this whole thing now? If this part's 5 and this part's 20, the whole thing is 25. Right? So anytime we do geometric mean, we're going to have two ratios. D is the geometric mean, so it's going to go here and here. The geometric mean between what? The whole thing and the piece that touches that line that we're looking for, so 5. So look what I get. I still get D squared equals 125. Same thing I got over here. So that proves that I could do it either way. It worked either way. Okay, this is just showing the second way to find D, which we just went through. So there is the exact value. Here is my approximate value if I punch that in the calculator. Okay, so you need to know how to use your geometric mean formula to find these parts of the triangle. It all is with respect to this altitude here. The altitude is the geometric mean. And the leg is the geometric mean. You have to know what they're the geometric mean between. That's your job, is to study those rules and know them so that you can apply them. Okay, so if we're trying to find E, how are we going to do that? E is a leg of this big right triangle, and 8 is the altitude, and 16 and 4 are pieces of our hypotenuse. So what is the length of the entire hypotenuse? It's 20. Okay, so our leg E is the geometric mean. What is it the geometric mean between? The entire hypotenuse, which we said was 20, and the piece of the hypotenuse that touches E, which is 16. Cross multiply, E times E is E squared, equals to 320. Again, take the square root of that, and what do you get? 17.9 to the nearest tenth. Notice it said to the nearest tenth, so I knew I had to get a decimal, plus my answers were in decimals. Okay, so we'll practice some more in class. Make sure you come in with questions and start learning those rules. See ya!